Next question is question number 28, and this question is kind of derivation. Okay, 3 नंबर का क्वेश्चन है, हमें पूरा डिराइव करना पड़ेगा, पूरा एक्सप्लेन करना पड़ेगा. Okay, so the answer is, question is that an AC source generating a voltage E is equal to, this E equal to E naught sine omega t. Okay, is connected to the capacitor C. यहाँ पर हमारे पास एक कैपेसिटर है और उस कैपेसिटर के अक्रॉस हमने एक अल्टरनेटिंग वोल्टेज सोर्स कनेक्ट किया है. दिस अल्टरनेटिंग वोल्टेज सोर्स हैविंग voltage E naught sine omega t. Okay, and this alternating current will start to flow, that is I, function of t, it. Okay, because this EMF is function of t, it is alternating simply. Okay, so for capacitor, listen carefully. For capacitor, you know very well this Q is equal to C into V. So if you are just differentiating this equation, you will get C into dV by dt. And what is this dq by dt? That is current I. But this current is variable, so you have to write down it, a small I. That is function of time, dV by dt. Okay. And in this case, what is this V? It is E naught sine omega t. So this it is equal to C d by dt of E naught sine omega t. That is the current. Okay, so this it, now this E naught is constant, so this epsilon naught, E naught into C. Okay, and this sign having differentiation cos omega t, and this omega again will multiply. Okay, here, so this is the expression for the current. So if you are talking about the peak value of current, that is peak value of current is equal to omega E naught C omega. It can written as omega E naught divided by 1 by C omega, and it is called reactance. So epsilon naught divided by XC. What is the reactance? Reactance of capacitor XC is equal to 1 by omega C. Okay, that is the reactance. So this IP is equal to E naught, that is the peak value of potential divided by XC. Okay, this IT now can written as IP, the peak value of current, into this cos can written as sine omega t plus pi by 2. Okay, okay, so this current is leading by pi by 2. This positive sign is showing that leading, this current is leading by pi by 2. Okay, we have to plot these E and I. Okay, the expression, find the expression for the current, already we have find it out, and plot E and I. Okay, and we have to show that this is the phase difference pi by 2. So it is clearly visible here. If we are talking about the potential, if we are talking about the current, the phase difference is pi by 2. Okay, so current and voltage having pi by 2 phase difference. Okay, phase difference, and current is leading by pi by 2. Okay, now if you are just plotting the graph, the waveform for the current and voltage. Okay, this is our y-axis and this is the time axis. Okay, so the graph for the voltage is simple sinusoidal graph, sine wave, like that. It is like that. This is for E. And for, okay, for voltage it is cos. You can write, sorry, for current it is cos. You can write this Ip into cos omega t. And how you will draw the waveform for the cos? That is this, like that, like that. This is the current It. Okay. So these are the waveform for the current and voltage. Thank you very much.